done 5E or you weren't here for 5E, highly recommend that you look at the video for it, or at least look at the annotated notes on OneNote so you can utilize that as well. All right. 5F. So on Monday, does anyone remember what we learned about? We learned about on Monday. Timesing, so or multiplying. What are you multiplying though? Okay, is it scalar multiplication or is it another type? Say that again, Zach, sorry? It's the other type. What do we call that? Well, it's there. It's in the title here. Okay, we're multiplying matrices with one another. Okay, that's what we learned about on Monday. And the basic principles are in the notes, but we'll go through it again in this problem here. But what we're covering today is now applying matrix multiplication to some application questions. Right, so it's more or less the same thing. It's just now you're going to apply it to questions or worded questions. Okay, just a quick recap maybe before I get into it. Okay, what are some rules? Does anyone remember any of the rules we learnt about when you're multiplying the matrices? Yeah, I'll put some of the examples here. Okay, what are some of the rules when it comes to multiplying two matrices together? What do you need to make sure that they're multipliable? Yes, Zach. Okay, so the number of rows or columns in A, so the first matrix must equal the number of columns in A equal the number of rows in B. So what he's saying there is, let's say, for example, you've got two matrices. I'm going to make them up. Let's go 1, 2, 3, 4. And you're multiplying it with, say, for example, okay, this matrix, okay? What you want to do first is you want to state the order of both matrices, okay? Tegan, I'm going to ask you, what is the order of this matrix? So when we talk about the order, I'm talking about how many rows by how many columns. So what's the order of this matrix? How many rows, how many columns? Now tell me how many rows. Count. You got 1, 2, yeah, 2 rows. Okay, so that's 2 rows right there by, Rocco, how many columns? 2. 2 that way. Okay, so it's 2 by 2. Okay, and then Kaya, tell me what's the order for the second matrix? 2 by 1. Okay, so what this tells you is the order for both matrices. Now, what Zach mentioned before is in order for these two to be able to be multiplied together, you have to make sure that the columns in this matrix is the same as the rows in this matrix. More or less, what he's saying is the middle numbers here have to be the same. Okay, so if they're the same, that means you can multiply them. Cool. Thank you, Zach. And what was the other thing about looking at the order of two matrices? What kind of information would that give us? What's the other thing we can derive from it? Something about the outside numbers here, or the row in this matrix and the column of that matrix. What does that tell us? I'm going to ask Natasha, what does this represent? Good, so it gives you the order of the answer of your matrix. So in this case, it's a 2 by 1 matrix. So when you multiply them, your answer is going to have 2 rows and 1 column of some sort. Okay, and then we go through it. All right, while we're here, let's multiply these matrices together. So I know that it's going to be some sort of 2 by 1. Okay, so give yourself space to do that. Remember as well, when you're multiplying matrices, it's row times the column. Yeah, row times column. Okay, that's the same. It's the basic principle for most matrices when you multiply them, row by column. All right, so let's do the first row. And remember, it's a 2 by 1, so you're going to have 2 rows and 1 column. All right, let's do the first one. So this is going to be this row times this column. So the first number is going to be 1 times 0. So 1 times 0 is what, guys? 0 plus the next one will be 2 times the 1. What's 2 times 1? 2. Easy. Okay, there's your first element, whatever it's going to equal to. Next one. Okay, same principle. It's this row times this column. Okay, so it's going to be 3 times 0. We'll give you 0 plus, we'll do 4 times the 1, okay, which is 4. Okay, so when you evaluate all of that, put it all together, 0 plus 2 gives you 2, 4 plus 0 gives you 4. There's your answer. Okay, and again, from what Natasha said, your answer should be a 2x1 matrix. Okay. All right, so that's how we multiply matrices. Now let's apply that to some application questions. All right, so here is an example. Cafe A and Cafe B charge the same price for coffee and orange and a muffin as shown. Okay, so Cafe A and Cafe B charge certain prices for their coffee. So they've got the price for coffee, OJ, and muffin. Okay, now the difference here, however, is it shows in this matrix or this information how much they would have sold on a particular day. Okay, so for Cafe A, they sold this many coffees and this many OJs and this many muffins. Cafe B had this many, and this many on that day. Okay, cool. Use a matrix multiplication to find a matrix that represents the total revenue at each cafe from these items on that day. So let's break this down. What is this asking us to do? Represent the total revenue. What do you think that might mean? Fahad, what do you think that means? What do you think representing the total revenue of each cafe means? What might that mean? Yeah, the total amount of money they would have earned based on their sales. So what I'm trying to do, or what I'm trying to find out, is I want to figure out how much coffee, OJ, and muffin they sold, but also how much money they made from selling that many for each cafe. Okay? And that's essentially what you're going to be doing for cafe A and B. But if you look at the question, it says using matrix multiplication. Okay, so you've got to multiply the values somehow to get the totals for each. Okay, so how do we do that? Well, firstly, let's represent these into a matrix. Okay, into matrices. So here you've got one matrix. So you're gonna have two matrices here. That's one of them, and here is the other. Okay, so in terms of representing these as a matrix, what I might do is I'm going to represent this matrix first. Okay, I'm going to make it into. Okay, actually, let me ask. If I want to make this into a matrix, what's the order going to be? 2 by 3, yeah? 2 rows, 3 columns. Okay, so 2 rows, 3 columns. Okay, and I might just, let's label it. So let's call this row A, B. Actually, let's say C, A, C, B. So when it's Cafe A, Cafe B. And then let's label the columns. So that's coffee, that's orange, and that's muffin. Okay, and let's put the elements in. So you've got 96, 24, 32, and you've got 1, 2, 4, 20, 16. Okay, that's the first matrix. Now the other matrix here, that I'm going to represent is this top one. Okay. Now you might be tempted, okay, because we're trying to multiply this, yeah. You might be tempted to think that, all right, I'm going to make this into, what order of a matrix should I make this? Okay, you might think it's a 1, 3. Okay, so let's try that. I'm going to put that in. Okay, so you've got coffee, OJ, and muffin. Okay, but what happens? What's wrong with this matrix? Okay, what's wrong with this matrix here? Say that again. It won't match up. Yeah, you can't multiply them, can you? Because remember, the principle is you're going row by column, but there's not enough numbers to multiply. So how should I then arrange this matrix? Have a think. If I want to multiply them together. 3 by 1. So it should be a column matrix of some sort. So let's fix that up then. Thank you, Anthony. So this matrix here, because I want to multiply them together, organize it like this. So this is going to be coffee, orange, muffin. And then you put your prices in. 3.5, 5. And now what that does is actually now allows us to multiply them with row by column. And what's good about that is it actually will give us the total. So for example, I wanted to multiply this with all this, it'll give me the total for it. Okay, do you guys see that? Similarly with the bottom row. This row with this column, it'll give me the total for that cafe. So now that I multiply them, or I can multiply them, let's evaluate it. So, well, actually, before I do that, what's the order of these matrices? Huckton, what's the first order? What's the order for this matrix? Good. And this one is a? Good. So, looking at that, I can see the middle numbers are the same, and my answer is going to be a what? What's the order of my answer or the product? 2 by 1, right? Because the outside numbers tells you the order of your answer. Yeah? So it's going to be some sort of 2 by 1. All right, so give yourself space. 2 rows, 1 column. That's CA, CB. Okay? I'll rip out my calculator for this because these numbers are big. So the first one, okay? First row, this column. It's going to be 96 times 3.5. Now, technically, you'd probably be able to do this on your calculator, so it'll be a lot easier. So 336, 24 by the 5. So 24 by 5, 120. And then the 32, oops, sorry. Then the 32 by the 4.5. So 144. Okay, there's your first row done. Let's do the second one. Okay, so you've got the 124 by the 3.5. So 124 by 3.5. So again, on your calculator, when you do your CAS, it'll be a lot easier. But I'll also show you guys how to do it by hand, because there's going to be times, okay, where you're expected to be able to do this by hand. Okay, but we won't give you any crazy 100. Any crazy like 4x4s times a 4x5, for example. It's a bit too much. So 16 and a 4.5. So 16. Okay, and that's 72. Okay, so there's all your values. Now we add them together. So you got to make sure you're able to do this by hand, guys. Okay, then just add them all up, and that should give you your value. So 336 plus 120 plus 144, 600. So for Cafe A, their revenue was 600, and for Cafe B, 434 plus 100 plus 72 is 606. Okay, and then if you wanted to, in terms of the question, if it asks you how much revenue did Cafe B make more than A, then you'll have to evaluate that. But essentially, that's what this question is asking you to do. Okay, so when you do these sort of questions, be mindful of how you multiply the matrices. Okay, there's going to be moments where you might think that, oh, I've got to make this into a row matrix, but then you can't multiply them because there's not enough values or the orders don't line up. Okay, and also what I've essentially done, again, there is basically found the values for each other. Let's move on. I might do this example, then I'll let you guys work. Okay, there's a few, actually 2 more examples, and that'll be it. Okay, let's do this one, but let's put it into in our calculator. Okay, so get your calculators ready. Make sure they're loaded. Let's put these into a calculator. And while you're getting that sorted, I'll read this. So the number of goals and behinds kicked by some teams during the previous round in some matches is shown in this table below. Okay, so you've got the teams and the number of goals and behinds that they kicked. Okay, so that's for all 4 teams here. And what they want to do here is you want to, and you've got the value of the goals and the behinds in this table here. Okay, so what we need to do is we need to now find in a matrix and represent the total number of points that they would have scored based on the value of the goals and behinds here. So firstly, let's represent this into a matrix. Now tell me, what's the order for this matrix, guys? It's going to be a 4 by 2. Okay, so 4 rows, 2 columns. 4 by 2. And let's put the labels in. Let's go A, B, C, A, and we'll call this CO. Okay, and then that can be goals and behinds. Okay, let's put the values in. So you've got 9, 9, 20, and 9, 7, 8, 15, 10. So that's one matrix. Okay, and then again, I want to multiply it with this matrix here. Now, Zaid, can you tell me the order of this matrix if I want to make it into a matrix? How many rows, how many columns? Good, 1 by, sorry again? 1 by, how many rows, how many columns? Good, 1 by 2, okay? But, think about this, yeah? If I make this a 1 by 2, can I multiply them? Okay, remember, it's row by column. There's not enough values, so it can't be a row matrix. It has to be a column matrix of some sort, a 2 by 1. So it's going to be 6, 1. Okay, and that's the goals and behinds. And now I can multiply them. Let's do this on our calculator so that y'all get to using your calculator for these sort of questions. Okay, so get your calculators out. Remember, for this, just go add calculator and then press that little button next to the book. Okay, remember what these represent. So that's a 2 by 2 row matrix, column matrix, and this is our custom. So for the first one, it's got 4 rows, 2 columns. So let's go, number of rows is 4, and you've got 2 columns. Okay, put your numbers in. So 9, 9, 20, 9, 7, 8, 15, 10. Now, does anyone remember how to label a matrix if you need to? How do you label the matrix?
Control variable.
Good. Put the cursor all the way to the right first, though, yeah? And then you go control variable, and then you call it whatever you want. I'll just call this A, okay? Okay, so every time I press A, that's going to appear. Cool. All right, same thing with the other matrix. Make another one. Jordan, how come your CAS isn't open? Yes. But still, should be following, okay? Control VAR, and let's just call this B. Doesn't matter. Okay, so I've got my 2 matrices now, yeah? A and B. So there's matrix A, and there's matrix B. And so now, all I'm doing is multiplying the 2 matrices together. So A times B. If you're really lazy, though, and you didn't want to label it, what you could do is you could actually just go, highlight the matrix, press enter, and it appears. Then you go times, and then just highlight the other matrix, press enter, and that'll also just do the same thing. But you don't have to label it. You can if you want to, or you can just do it that way. I find that labeling does help a bit because there's going to be a few questions where you've got like 5 matrices to work with, and can't be bothered looking through and writing them down. So there's your answer. That means that's the total number of goals and points for the team, well, each team. All right, so you got A, B, D, A, C, O, 63, 2, 9, 50, and 100. All right, any questions? I think this is a similar example, so I might move on. Okay, let's move on to here, and then you guys can start working. So what you guys actually just did is an element of what this is, which is what we call a summing matrix. Now, what do you guys notice about these 2 matrices, this matrix and this matrix? What's interesting about them? Nothing. Well, there's something. Okay, how many columns do they both have? 1. Okay, they all have 1 column. Okay, and that's an important part of your summing matrices. Okay, whenever you multiply, for example, a matrix that has 1 column, okay, what it does, depending on the numbers there, okay, but normally when it comes to summing matrix, what's cool? What do you see about these entries here, these elements? They're all 1, okay? So what happens is, if you multiply all of these by 1 with this matrix here, what it does is it adds all of the elements there together. Okay, that's why it's called a summing matrix. So this summing matrix here, okay, when you multiply it with the column matrix, what it does is it adds up all of the rows. Okay, so it adds up all of these rows, it adds up those rows and those rows. So it basically gives you the total of all the rows. Okay. What about this matrix here, the column matrix? What will this add up? The columns. Good, because if you multiply all of these with 1, okay, it's going to be 5 plus -2 plus 7. Okay, it's going to add up all of the columns. Okay, that's what a summing matrix basically does. So without reading through too much of that information, okay, a column matrix, so look at the location or the position of the column matrix. If there's a question that tells you add up all of the rows, so add up all of this, then use a column matrix and it goes on the right hand side. Okay, if you want to add up all the columns, okay, use a row matrix and it goes on the left side. And again, that's because of the order of the matrices. So see how this is a 1 by 3, this would be a 3 by 4. The middle numbers have to be the same in order for you to multiply them. You can't do this, for example, if you went and did times 1, 1, 1, okay, you can't do that. Why can't you evaluate that? Okay, there's not enough rows and columns to multiply with, so it won't work. Okay, so just be mindful of that when you multiply these. Cool. Another thing as well I might add is you're going to get asked to come up with your own summing matrices. So normally with a summing matrix, all of the entries are going to be 1. Okay, the only thing that you got to work out or think about is how many elements are they going to be. Okay, so for example, in this matrix here, if I want to add all of these up, okay, I need to multiply them with 4 separate ones, yeah, because there's 4 numbers. So in my column matrix, I'm going to have 4 entries or 4 rows. What if it was this? Okay, what if I wanted to add up the sum of all of these rows? What would I have to multiply it with? Some sort of column matrix, yeah? But how many entries in my column? Have a think. I've got to add these 2. So you're going to have 2. Okay, 2 ones in there. Okay, and the other way, 2, 0, 1, 2, 2. If I wanted to add up the columns, okay, so I would use a row matrix. How many entries will I need? Well, I need to add up 3 values, so it's going to be 1, 2, 3, because I need to add up all of these. Okay, this will make more sense. I'll leave that there when you put it to practice, but that's essentially all you need for this. So what I'll do is I might get you guys to work now, and then we'll go from there. So if you're following along, please follow along with me. In this example, what it's asking us to do is you've got, well, actually, let's look at the context. You've got the schools and the number of classes in each of the math subjects that they do have, 4 different schools. So because it says 4 different schools, I'm going to assume that these are the schools, 1, 2, 3, 4. Okay, and these are the subjects. Okay, so let's call these schools, and these are the subjects. Don't know what the subjects are, don't know what the schools are, that's fine, but just so you know that these are the schools and those are the subjects. Okay, so what it's asking us to do here is multiply A, which is this is matrix A, by a suitable summing matrix of some sort. So that means we're going to be using either some sort of column matrix or a row matrix that looks like this. So it's either one of these matrices. So that's a row matrix. Okay, and this here is a column matrix. Remember what they both do, yeah? A column matrix like this goes on the right-hand side, and what it does is it adds up all of the rows. Okay, a row matrix like this goes on the left-hand side, and it adds up all of the columns. Okay, and they all have 1s, and the number of elements in the matrix is determined by how many you need to add together. So for example, in this matrix here, if I want to add all the rows, all the columns up, okay, that means I'm adding these 3 values. So you're going to have 3 values or 3 1s in that summing matrix. Okay, so let's do this one. Multiply A by summing matrix to find a matrix that gives the total number of classes in each subject. Okay, total number of classes in each subject. So if you have the subjects here at the top, okay, what is it asking you to do? What are we trying to add here? The total number for each subject. That's what he's asking us. So what do we need to add here? What am I adding? Tell me. What am I adding here? Adding the columns. So I want to add all of these together. Okay, so if I want to add all of the columns, what am I going to use? A row matrix of some sort. So let's put that in. My row matrix. So if I want to add these 4 numbers, how many elements do I need in my row matrix? 4 elements that go in a row. 1, 2, 3, 4. Multiplied by, so this is question 8, that matrix there. 5, 7, 8, 5, 4, 2, 3, 8, 1, 1, 2, 3. Now, if you're a smarty pants, okay, you could probably just do this in your head. It's not that hard. But just be mindful of the order, yeah? This is a 1 by 4, and this is a 4 by 3. So that means your answer is going to be some sort of 1 by 3. So 1 row, 3 columns. Okay, I can do it in my head. 1 plus 5. Basically, I'm just adding all of this anyway. Okay, so in terms of working out, you don't have to show, 5 plus 7 plus 8 plus 15, 5. There's too much, okay? You can just do this in your head, I would say. So adding them all up, 5 plus 7 is 12, plus 8 is 20, plus 5 is 25. So 25 for that first one. So that's all 25. This one here, 4 plus 2 is 6, plus 3 is 9, plus 8, 17. So that's all of that. And then the last one, 1, 2, 4, that's 7. There it is, easy. Okay, not a lot of working out involved, but you at least have to show that you understand that it's a summing matrix of some sort. Okay, for B, okay, the total number of math classes in each of the senior schools. So each of the schools here, total number of math classes, what you're adding now, okay, is the rows. So you're adding the rows for this one. Okay, so in this case, if I'm adding the rows, what am I going to do? Okay, you're using a column matrix if you want to add all of the rows. So it's a column matrix on the right. Okay, so you've got that matrix 5, 4, 1, 7, 2, 1, 8, 3, 2, 5, 8, 3. Multiplied by some sort of column matrix. It's on the right hand side. And how many elements in my column matrix? Because I want to add these 3. There has to be 3 1s in there. Okay, and again, the order is, this is a 4 by 3, and this is a 3 by 1. So my answer is going to be some sort of 4 by 1. 4 rows, 1 column. Okay, so 4 rows, 1 column. All right, so adding all of these up. Okay, that's what I'm doing. So 5 plus 4 plus 1 will be 10. 7 plus 2 plus 1 will be 10 as well. 8 plus 3 plus 2 is 13. 5, 8, 3 will be 16. Okay, and there's all of my rows added together. I know we're adding, okay, but again, in your SAC, you've got to show this sort of working out. And you got to tell me that you're using either some sort of row or column matrix to add them up. Okay, that's the main important thing that we look for in your SAC and how we mark it. And that's basically it. Okay, cool.